All right, testing. I think we got it fixed. Testing. Yep, I got audio clipping finally. Let's see here. Home. All right. Yay. Now that we're fixed and I can see that I'm talking because the thing's moving. All right, if you're in here, say hello and let me know you can hear me. Yes. Yes, everyone can hear me. Sweet. I don't know what happened. I don't know why it went crazy, but it did. And I don't know why, because it was working fine the other day when we tested this thing out. So get this straight. Now I can see the little green dots moving across the bottom. So back to where we started. A little bit about me. So I've been doing this for 26 years. I have my master's in HVAC and residential gas. Yes, Jen, if it wasn't chaos, it wouldn't be you. um, I enjoyed teaching, and when I got with Jennifer on this, I said what I wanted to do some start with basics because a lot of our tech calls are on this situation here. So we're going to do a 5-part series of basic low voltage wiring and controls to help out younger techs and even newer guys sometimes forget these things. So I had to make sure I wear the official Chicks shirt. This will be the shirt I'll be wearing every time I'm doing this live. So get used to it. Um, Hopefully you won't see this right here soon. I'm waiting for a different camera to come in so I can set that off to the side and have the computer over here so it's not in the way. So you don't have that going. So, all right. So as you can see on the board, I've got a bunch of terminals. Some of these you should know, various, and some of these you should not. You don't know. So we're going to go over not just one standard brand of equipment or anything. Feel free to ask questions. I can see the chat. If I'm going too fast for some of you, let me know. But here to have fun and hopefully educate a little bit, just refresher and educate people who don't have this. So we have our terminals. R, 24 volts. Everyone agrees. C is common. And sorry for the writing how it goes, but that's what we're going to deal with. Y. Now, this is where everyone has the wrong answer. Even when I did this in class, people were like, "Oh, done." I was like, "Nope, that's the wrong answer." Tell me what you think Y is. I want to see it in the comments. What do you think Y terminal stands for? Because some people will give me the wrong answer, and when I tell them the right answer, like, but that doesn't mean anything. And it's like, yes, but you also got to think. You're also not just thinking AC or heat pumps or gas. This is terminals for across all systems all at once. So call for what, you guys? So, all right, so you got Y for cooling. What else? Who else does something different? Anybody? And I'm doing this as if I was sitting in a classroom and y'all were sitting in front of me. So, and don't feel bad if I pick on someone. It's just I call people out to educate, and I'm not picking on anybody. It's just how I've done it. And most guys are like, "Oh, oops, yeah." So, all right. So, why is cooling? Well, yes, it brings on it. Get it right. Why actually is your compressor contactor? Okay. All it does is it brings on the compressor for the system. It doesn't designate whether it's cooling or heating. If it's a straight AC, yes, it brings on the contactor for cooling. But in a heat pump, it brings on the compressor and something else tells it whether it's heating or cooling. And that's where these next two terminals come into play. O and B. What does our O terminal stand for and what does our B terminal stand for? Now, different brands, B stands for something different. Okay. But for general purposes, O and B are going to be the same thing for us. All right. So O is our 24 volts cool reversing valve, and B is our 24 volts heat reversing valve. So even though Y is calling, if it's for cooling, this is going to energize on a heat pump. On a straight AC, this won't be there. Y will energize and bring on our compressor contactor, which in turn makes it cooling. So RVs are reversing valve. If we do anything, it's going to be CC will stand for a compressor contactor, so I have to keep writing it out. So now this next one, G, depends on the type of system you're working with. So if you're working with an X13 motor, there's really not much, not going to understand what this is. But if you're working on an older system, this is your indoor fan relay. Okay. So when G is called for, it energizes a relay, which in turn brings on the fan. Now, depending on what manufacturer it is, depending on what kind of relay it is, if it's an older carrier, it's a circuit board. If it's a train, it's a 9340 DC volt relay. And yes, I did say DC volt. And when we get into the next few sections down, we'll have relays and controls that talk about low voltage and how they operate each relay. So we have our indoor fan relay. Now, you got W, W1, W2. So depending on the type of system, depends on what each terminal is actually going to be. So if you have a gas furnace AC, you're going to have either a single stage, which will be W, which will be heat. If you have a two-stage gas furnace, first and second, heat. Almost forgot two terminals. Now, depending on thermostats as well, these terminals are specific for certain type of systems with thermostats. Now, if you're messing with a Nest, okay, and your Nest thermostat, let's say you have a two-stage heat pump with auxiliary electric backup, you're going to have a W1 and W2 on your Nest. W1 is where you want your white wire. You do not want to wire W2 because then it's going to think, okay, I'm gas or I'm a dual fuel. Okay. If you mess with a Nest, don't. Yes, I know. A lot of us can't stand Nest. But I had one the other day that this was the issue because someone wired it incorrectly, and I had to go through rewire everything to get it to work properly because the system was thinking it was dual fuel and it was a two-stage heat pump. So on a two-stage heat pump, W1 is going to be our auxiliary heat. And if you don't know what auxiliary heat is, that's your backup heat. And then if you're dealing with heat pumps, that's electric heat strips. So now you got Y1, Y2. Well, being as we got your Y as your compressor contactor, what would a Y1 and Y2 be? First stage, second stage. So now, if you're messing with the train, it's not going to be a Y1, it'll be a Y low and Y2. Okay. So first stage compressor contactor, second stage compressor contactor, or first stage compressor contactor, second stage relay. Because we all know the two-stage compressors have a relay that energizes through the DC volt term into DC volts, which hits the unloader. So first stage, second stage, either contactors or relays, however you want to do it. They're going to energize either one. Now we're going to move over here real quick. E, everyone should know what this is. Yes, glad I got that figured out too. I'm just going to abbreviate it. Emergency heat. Now, if you have a dual fuel system, that would be gas or oil or hydronics. Depends on what you're using. But E is always going to be that type heat. Aux, we all know what that is. Auxiliary heat, which in terms, depending on the type of system you have, if you have a heat pump with electric backup, when the heat pump is running and the emergency heat elements kick in, they're considered auxiliary heat. Now, you cannot run a heat pump with a gas because you'll mess that heat pump up. It'll kick it on high head pressure and everything else. Same with the hot water coil. The hot water coil, you can't, usually you'll have that above it. So you're going to be pushing heat pump air over a hot water coil. That can happen. Oil furnace, you're not going to have this running along with an oil furnace because again, it's just like a gas furnace. You can't have that. But auxiliary heat is basically a third stage heat for a heat pump. Okay. Now, if you have, let's say, an electric furnace with AC, you're going to wire it up basically like a gas furnace AC because it's just electric versus gas. So now we're going to talk about these other lovely terminals that we have here. And we're going to start with the L. Some people think this is L means something totally different than what it actually is. It is not a lockout. It is a fault. Okay. With that fault, if you know a certain manufacturer, and we'll just put the main name that everyone knows, York. On their circuit boards, they'll have a purple wire. That purple wire on their defrost board is a fault light that will go back to the L on your thermostats, which y'all like trying to figure out what that meant. That's what it's for. That red that will go to the thermostat, and then the red light on the thermostat, the emergency light, will flash in accordance with the defrost board. Which, and then your homeowner calls you up and says, "Yeah, my thermostat's got a red light blinking at me. What's wrong with it?" Then you go, "Oh, how many flashes is it?" And it tells you 5 flashes. Okay, well, if your dispatcher's somewhat decent and knows, and and your technicians or whatever, they'll go, "Okay, well, that's your high pressure switch lockout. It's kicked out. We need to figure out what's going on with it in the heat mode. She might have a dirty filter." And you go out to the customer's house, and sure enough, they got a dirty filter or the blower motor stopped. It kind of gives you an idea of where to go for diagnostics. I don't like wiring this up because this is basically a idiot light and it's a nuisance call for you. As long as the unit will reset itself and restart itself automatically. And then once does it 3 or 4 times, it locks out. So the defrost board will shut itself off and keep the system from running if it continues to have a fault. X. Now, this one here, a lot of the new guys won't know what this is. A lot of the older guys will know what this is. But on the old mercury bulb thermostats, we didn't have a common. We had X. And that's on the mercury stats. Okay. And then if we take, and I'm going to put a slash up here, the B is for train. Train used B for common on the mercury bulb thermostats because they didn't have a B. They didn't need B, but they had B for common, where everyone else uses B for. Everyone else uses O. This is Ream Manufacturing, which is Ream, Rude, and Weather King. The main line uses it. Bosch uses it. And the True Temp by Train uses it. Now, why does True Temp by Train use it? I don't know. They had to be something stupid and difficult with it to make everyone aggravated. Not to mention the True Temps didn't have when they first came out through as a Maristar, they did not have a true suction port, so you could only charge them in cooling mode. So now P, this is brand specific. This is the Ream Manufacturing as well. Now this falls back into the late 80s, early 90 units. This was 24 volts. Okay, so if you saw a purple wire, if you get an old green air handler, when I say green, I'm talking green. It had a Phillips head screw on top to take the top door off. That air handler style there did not have a red wire for 24 volts. It had a purple wire. Okay, that's what they did. Now, the purple wire is now defrost. So yeah, so now it is a defrost wire on Ream and Rudd. So when you're looking at your outdoor unit, you see a purple wire, no white wire. That's what that goes to. Now these next two, 66 and 60. This is both York Manufacturing. Okay. Now, don't ask me why they do this, but they do. It's aggravating. This is your W terminal in, W term out. So what York does, so you're wiring up an air handler. You take your white wire for your auxiliary heat, for heat strips off of your W1 terminal or your aux E terminal, whatever thermostat you're messing with. That goes from the thermostat to the outdoor on a W2 in. Okay. It then in turns and sends it out on that terminal, W2 out or 66. So it was 66. It says W2 in, out. So it brings it brings a 24 volts in and sends it back out. So what happens is that way it says, okay, it has an outdoor ambient temperature sensor. And on the defrost board, you can set the little pins or whatever to say, I don't want the heat strips to come on but above a certain temperature. If it's not, the board just kind of says, okay, I've been running a heat pump for a long time. Let's bring on the auxiliary heat if I get a call for it. But it won't let it do it for certain reasons internally in the board if it doesn't have those pins. So that's what York does. W2 in and W2 out. York also brings Y2 into the board on the outdoor unit and then Y2 out to the air handler. So you take Y from the thermostat to the outdoor, then from the outdoor to the indoor. Why? I don't know. That's their design. And if we had Gene in here, he'd go, Jennifer! But we don't because Jennifer's not doing this. I am. So this is our basic connections, our basic terminology on what everything does. So I'm gonna give everyone a minute to make sure they have this all written down and they can see everything. Is and guys, if you don't have, you know, it's gonna be posted on the Chicks page up there. I'm gonna delete the previous one and I'm gonna bring this one on there. So that way this one here is the main one. Um, so they'll all be able to you to go back to and check and read and watch and everything else. Send it to your friends, send it to your coworkers, whatever. So we're gonna hold on, let y'all write this down if you want, take a picture of it, give you about a minute or two, and then I'm gonna erase all this and we're going to the second part of this. Monthly training group 2. Sweet. And hopefully we won't have any more audio or video issues. I don't like the erasers. I use like this right here. I like these much better. Yeah, that stuff is. Whew. Any questions on this so far? Screenshots are your friends. Yes, they are. Anyone have any questions that's in here on what we've on any of this? Any terminals you haven't seen? Any terminals that I've discussed that you haven't seen? Yes, cameras are your friend. All right. Time to go on to the second part of this lovely low voltage terminals. Now, this next part is class participation. So I hope everybody participates. And it's real simple in this next part. It's just punching a letter and hitting enter. All right. The S terminals. All right, we'll go over to that real quick. So you have two terminals on thermostats, and usually they used to be S1, S2. Now there's S1, S1. Depending on what you have wired, you want to use it for, you can use it for a remote, indoor, indoor sensor, or outdoor temp sensor. So now some people want to use this as a remote indoor to have a average of the room. So if you use it as a remote indoor sensor, it will take an average of the two readings of the sensor and the thermostat and use that. If you're using it for the outdoor, it just displays your outdoor temperature sensor. So that is your S terminals. Any other terminals anyone's got? Yeah. So, all right. Here we go. Let me back up and let it auto adjust. All righty. So as you can see, we have two bars, 24 volts, common, all right? So we're in the cooling mode. This is the crash potentiation part. This is where you go into the chat and you type in a letter and you hit enter. When we're in the cool mode, what terminals are energized in the cooling mode? So you have Y. What else? And if we have multiple terminals like Y1, Y2, W1, W2, those are all covered under just the basic terminal. G, O, anything else? I'm making y'all think for a reason. All right. What terminals are not energized in the cooling mode? Well, we'll get to that, the hints after we get the basics down first. So what terminals are not energized in the cooling mode? All right, we got W. What else? So W covers all your W's. Okay. E. Got y'all thinking. And there's yes, B. There we go. So we got W1, W2, W3, E slash aux, B. Nope, R's already right here. And C is right here. So R, Y, G, and O, right? Those are our main terminals on a heat pump because R sends a signal from to Y, which also sends a signal to G and sends a signal to O for cooling, right? So now that we have the basics here, let's go to heat. What terminals are energized in the heat mode and what are not energized in the cooling mode, heat mode? So let's start with the energized in the heat mode first. What terminals are energized in the heat mode? What else? We got our W, our E, our G, our B, and our Y, right? Got E, got our B. What's not energized? Was it A? I don't know what terminal A is. O. Don't confuse them, Mike. So this covers all our W's. E slash aux covers our G, covers our 24 reversal of heat. This covers all our Y's. So let's go over here to the cooling. If I take a voltage reading from Y to O, what's my voltage reading? Zero. This is because anything on this side of the line all has 24 volts applied to it. If I take a voltage reading from O to B, what's it going to be? "24 volts." Anytime I cross this line right here, I'm going from a 24 volt to common terminal. Okay. So G to E, Y to W, Y to B, Y to C, anything on this side is considered common because these are not energized. These are dead basically. They're commons. Back in the day, we used to use a T87 and you had to use a resistor as a common because there was no common terminal, and it would use that as between a W and a Y terminal. So that way, resistor would use that as a false common, basically. So anything from this side to this side, you get 24. Anything down this side, I should get 0. Now, what if I go between common and E? What do I get between common and E? 0, because there's no power there. Okay. So what we have here is the same here, right? Anything that's under this R terminal, when it's energized, all these have 24 volts applied to it. If I take a reading from this side, from here to here, I should read 0 volts. Now, if I go from here to here and I read 24, what happens? If my thermostat is set for heat and cranked all the way up, and I go between Y and G just checking to see if I checking my voltage, and I read 24 volts between here and here, what do you think the problem is? Short, breaking the wire basically. Could be a bad thermostat. Well, if the fan's dead, the relay, you're still going to get 24 volts off the thermostat. So if my thermostat, I should have 0 volts between here and here. But if I'm reading 24 volts, either I have a break in the wire or I have a bad thermostat. Because if I go between G and common, I get 24, and Y and common, I get 24. That means I should read 0 volts here. But if I go between G and common and I get 0 volts, okay, and if I go from here to here and I get 0 volts, but I'm getting 24 volts over here, that essentially means G has been moved to the common side of the line, which means it's not getting a call from the thermostat. Thermostat's the only thing that can send that voltage out. So if you guys are ever on a service call, knowing how what's energized and what's not energized, if you're on a service call and you put the thermostat to cool or heat or whatever, and you should be getting 24 volts between Y and common, but you don't have it at the air handler. Okay, because you can't really pull a thermostat off the wall to check the voltage there. So you go to the air handler, you check Y and common, you got 24 volts. But the thermostat's calling, the fan's running, but you're not running. Most 99% of the time, the problem is your thermostat. So if I get a call for heat and I don't have any voltage and my fan's not running, but my compressor is, most likely this not getting a signal from the thermostat. And if you're getting a call for the only other way you can do is if you have a battery powered thermostat, flip it over, put your meter continuity and check there and check. Now, there's two terminals I did not go over. I did that specifically for this right here. RH and RC. Okay. Yep, exactly, Mike. So if you look on thermostats, especially like the T4s and T6s, you'll see right here in the bottom right, you'll see a RC, RH, and you have a switch right here, one or two. Okay, and depends on which way it's up or down. So if it's up, you're only going to use it'll push it up to here and block the RH. If it's two, it'll push down and bring this block down to here to the two wire, which means you have two wires coming in. Okay. This is for, let's say you've got a gas boiler and a air handler. Okay. You want one thermostat to control both pieces of equipment. So the gas boiler would wire up RH and W, and the air handler would wire up RC, G, and Y in common. The boiler doesn't usually use a common, so that's why you only have a RH and a W. But the air handler, your 24 volts common, or I mean 20 volts cool, your G, your Y in common. And your common from the air handler common is the thermostat. This just becomes a dry switch, basically. So this right here is important as well. So you can take two pieces of equipment and control them off of one thermostat if you have the ability to do an RH and an RC. So if you guys are in areas, let's say like New York or up north that deals with a lot of heating and very little cooling, and they have an air handler, and they have a boiler, and they want to control one thermostat, or they have two thermostats, they have an old T87 round gold thermostat for the heat, and then a digital above it for the AC. You can in turn and make this all one control by using 24 volts heat, 24 volts cool on one thermostat. And I purposely left these two out just for this section here because this is where you can divide and conquer the systems. Y'all getting screenshots and writing this down? Are your brains smoking yet? Do they feel fried? Well, Randall, this is why I wanted to go back to basics because even as a tech that's been doing it forever, sometimes these things you you know most guys who go straight out as from training to a service tech, they get blinders on and they just focus straight in on one thing. When you go through from the beginning of an industry, starting out as a helper and installs and new construction and everything else, and you've started from the bottom and worked your way up the service, you generally have a broad picture of everything. Okay. And you start overthinking things as well. But sometimes you get a broader picture, you can go, this can be this. But for right now, we're going to start with the basics, start with low voltage controls, everything low voltage wise of a system, and make this just with a nice, easy training thing. So everyone can start to go basics and go back and go, yep, That's what happened. So starting with this here, the basics, the heartbeat of the system, this is where we need to start. I don't care what manufacturer, what equipment you have. If you don't understand this and don't know how to this, it's where the problem lies. Now, when we get into the schematics of this, it's going to be fun drawing schematics, but I'm going to try and draw schematics as best as I can so people can understand them. But now I have the schematics drawn up on the board. If I have to buy a second whiteboard with the swap them out, I will. But this is our basics first, understanding this. Connor, you good? Marco? Yeah, when I do this here, I tell people why, I ask them what the Y terminal is. They tell me it's cooling. I said, what about a heat pump? It's cooling. Well, if you energize a compressor contactor, what tells it's cooling? The Y terminal does. And I'll get students who argue with me, they're the blue in the face, and then I say, it's compressor contactor. And then I explain to what the O terminal does. They go, oh, shit. Yeah. Everyone has misconceptions or misunderstandings, and it's a matter of breaking that and bringing it back in. Cool deal. So yeah, so it's a matter of retraining your brain on the simple things of the industry. Low voltage is the basics, understanding what it does and everything else. Yes, there is a Discord. We get in there every on Saturday mornings and do a tech talk and just BS for about an hour or so. Um, Unfortunately, the moderators, me, myself, Mike, Dan, and Jennifer, will get in there and a couple times a week and start talking and get on an off track subject. But yeah, we got this set up through there because I've been wanting to do this and give back since I'm not teaching right now and I enjoy teaching. So everyone's got this. Everyone good on this? I'm gonna take it down. Yeah, why? Yeah, it's a it's a misconception, Connor, and when you're dealing with, like I said, up north, like New York area, where you mostly have like gas furnace boilers and oil boilers and stuff in houses or gas furnaces. You don't have a lot of heat pumps out there. I tell you, coming from the, yeah, basically, why is your compressor correct, Marco? Yeah, and heat pumps up that way, totally different. Now, Boston, yep, my brother's up there in Maynard, so I know the area very well. I did the most touristy thing when I went to Boston last Memorial Day weekend. I went to Cheers and walked down the steps and got my picture opening the door to Cheers. The most touristy thing you can do in Boston. So, now there's one set of low voltage terminals that I did not go over, and that is those four right there. Okay. These four terminals, if you don't know, you'll know in a second. If you are messing with a DC volt communication system, this is what you'll have. Four wires. And it's usually, I'm not saying these exact colors, but you'll be dealing with a red, yellow, green, and white. That's it. Those are the only four wires you will mess with, from the thermostat to the indoor and from the indoor to the outdoor. Now, depending on what outdoor manufacturer you have, sometimes you only use two of those four wires. Why are you mad now, Marco? A B C B? No, A B C D. Alpha, Bravo, Charlie, Delta. Yeah. So if you're messing with, so like my house, I have a Carrier Infinity 18 SEER system. My thermostat has A, B, C, D. Four wires: red, yellow, green, white. My air handler has a terminal block that says A, B, C, D. It takes four wires. My outdoor unit takes two wires, green and yellow. So my outdoor unit runs on these two wires only in a DC volt connection. My whole system runs on all four of these terminals on a DC volt communication system. And if you did with the Bosch, if you ever put a Bosch in, you do not, you have your Y, your W, your common, and B. No R terminal, because they don't want an R out there. They have as being powered off the 240 into the inverter board through R that way. So if you have a communicating system, this is all 12 volts DC. Keep that in mind. Don't think it's going to be 12 volt, 24 volts AC. It's all DC voltage. Your air handler, your transformer is 24 volts AC. And when it plugs into that board converts it to DC voltage. And then it communicates through all three pieces of equipment uh, as DC voltage. Basically the same with your mini splits. You have DC voltage communication as well. Now this is a lot harder to diagnose out in the field unless you have the tech guide manual from the manufacturer tell you what voltage you're supposed to be reading when messing with these. Okay. York used to be able to had a plug where you could do A, B, C, D, or you had your normal wiring controls as well. And you could either make it a communication or non-communicating. I had a system that the communication side went bad on. I rewired the system as a regular thermostat, regular system, and everything went great. But this is all 12 volts. Let me put that 12 right there. I'm going to take this out right here so it's no confusion. But yes, so this is where you're at on your low voltage in this. You can be getting, say this is your 24 volts, 12 volts R. This could be your 12 volts common. But then you have these two here on the outdoor. So then this could be your 12 volts common. That could be a 12 volts R. So there's different ways on how you can read this thing and what could be what. What is this? I will say this. When I do diagnostics and I'm talking to tech support, they always have me going off of A to each of these. So A, as far as I'm deal with, is what they can deal with Carrier and York. A is always your 12 volt supply. And then B, C, and D relay back and forth and communicate. All right. You guys have any questions on this? All right. So I'm gonna give about a little bit of time. What questions do you have so far on anything we've covered so far today? I put down an hour to an hour and a half on this. We missed about 20 minutes about messing with this, so it's about right time frame. But I wanted to go over basically an hour of class and then have up to a half an hour for answering any questions you may have. And that's how it's going to go every class. We'll do an hour of training and then open it up for a half hour discussion of questions or anything you may have. So whatever you have, ask away. That's what we're here for. Okay. So when I've done diagnostics on the um, communicating systems, they've always had me check A. From A to B. So from A to B, A to C, and A to D, which told me in my brain of thinking, this is my 12 volts DC supply. Okay. So that's basically like my R. So this is just like my R terminal. Okay. Then, depending on what the system is doing and what it's calling for, if it's calling for heating or cooling, emergency heat, you're going to have a different voltage reading between these terminals here. Okay. Remember, it's AC volts, not DC. It's DC volts, not AC volts. So it's a direct current. It's not flowing back and forth. So we're going direct shot of this could be A to B could be 7 volts. This could A to C could be 5 volts, and A to D could be 12. Okay. Each one tells the system to do a different thing on the signal it gets. And 9 times out of 10, if you're messing with the communicating system, you need to call factory tech support because I have to call factory tech support because I don't have that booklet in front of me like the factory tech reps do that says what signal's going where. I've asked for it and they won't give it up. I've asked Train for it, I've asked Carrier for it, I've asked York for it, but they won't give it up. So when it's calling, it's don't think of it as 0 volts AC. Always just remember if you see a terminal, a system that has only 4 wires, okay, and it could be 1, 2, 3, 4 on the board, but ABCD is basically common. Um, no, it's not switching. It's always going to be when you have your circuit board, okay, right here, you'll have your block that has your ABCD right here, right? 24 common from your transformer. Within this, there's a little box in this board that converts AC to DC, and that goes there. So, no, once the 24 volts goes in, it converts it over to DC. This is always going to be DC voltage. You'll never have to deal with any AC voltage here. It's always DC. But like I said, you'll have to most likely, if you have a communicating system, you'll have to call tech support for that manufacturer because they have the Bible that tells you what your voltage readings are. Okay. You know, I still have to call them, and I've been doing this for 26 years. Okay. It's not something to be frowned upon. Like, oh, I had to call tech support. Some people are like, oh, tech support's terrible. I haven't had issues with tech support, so I don't have a problem calling. But just know you're not going to be running AC voltage through these if you have it. If you go up to a job and you see ABCD, you are communicating it is a DC volt signal. You'll know by your thermostat. You'll know by when you try to take a voltage reading on AC, it doesn't give you any voltage reading. You switch to DC, you get your 12 volts DC. These are more like a computer engineered diagnostics because of what they are, where we are not computer engineers. Yeah. So I just wanted to touch base on this just so if you guys did see this, Marco, you would know this is not an AC voltage system, it's DC voltage. Because some people think that that is there. That is the same. Multi-stage, they're simple, Connor. Um, so you have on your thermostat, you'll have your R, Y1, Y2, W1, W2, G, and common. I'm gonna keep this simple as a gas AC because I know most of y'all are dealing with gas furnaces. Um, 24 common fan. If you're doing this is first stage compressor contactor, second stage compressor contactor, first heat. So on your gas valve, you'll have high, low, and you have three terminals. Common, this will be your high, 24, and your low, 24. Okay. So depending on if you're calling for your second stage of heat, you should have power here on your high. If you're calling for first stage, you should have it on your low. Okay. Same with your outdoor. If you have, here's your compressor contactor, it's your first stage, and then here is your second relay. Okay. So that will go there, and this will go to that relay, which will in turn send to your plug on the side of the compressor, which is now remember we talked about DC voltage. This relay does the same thing. It converts AC to DC, which turns it into a DC volt relay. Okay, let me try and get that a little bit closer, like that. So that there. Now, yes, when you have, oh, shoot, excuse me, my back leg just kicked it out on me. Your inducer motor will have two stages as well. You'll have three wires going to it as well on your inducer motor, but that's on the high voltage side. We're just mainly sticking with low voltage for this settings. Stupid auto light. So yeah, your inducer motor will have three wires going to it as well. It'll be a black, red, and I think it's a green and a brown. Green, of course, is your grounding wire. Brown, I think, is your common on that thing. But yeah, it'll have black and red, which are basically your two speeds for your inducer motor. And you'll look at the board, it'll tell you it's a two stage. You look at your gas valve, immediately tell you your gas valve's a two stage. On the gas valve is AC volts. Gas valve is AC. The only thing that gets DC volts on something like that is your second stage if you have a relay on your outdoor unit. Everything else on this is all 24 volts. And your blower motor will have two speeds for high and low heat and high and low cooling as well. Don't get me started on modulating systems. They're even stranger. So if Y2 is called, it goes to your second stage relay. Y1 will always be energized, and this goes to a relay, which in turns opens up, sends a DC signal to that power plug in the back of the compressor. So if you see two plugs on your compressor, your front with the front one's got three wires, your back has got two wires. That's a DC signal that's saying it opens up the unloader and the scroll. And same with heat pumps. When you have a two-stage heat pump, same thing. Now, yes, that's all that little relay is, a rectifier. It's built into it. Yeah, so when the second stage opens up, it opens up the unloader and allows the compressor to run at full capacity. Now, if you're dealing with a two-stage heat pump, same thing. If it's a two-stage system with a single-stage stat, jump Y1, Y2, you can, but then you're not getting the dehumidification that a two-stage system actually allows it to do with the two-stage stat. It's always good to have the proper thermostat on there. And trust me, I've seen people do that. It works. It'll get you out of a pinch. It makes it a single stage system. The only time I'm okay with that being done, Marco, is if you don't have enough wires on your thermostat, from the thermostat to the equipment. Because sometimes back in the day, they ran a 5 wire versus a 6 wire or 8 wire. So if you put in a two-stage heat AC on a gas furnace, guess what? You're not going to be able to initiate second stage because you don't have enough conductors. Now, they do, Marco, they do make a control box system that allows you to take that and make it a two-stage. Honeywell used to do it off our IAQ 8000s, where the indoor thermostat was a 4 wire connection that actually DC volted into a computer, a little control board, and that control board took that DC communication and turned it to AC and sent the signal out on the wire in the system. So they did make a control that way back in the day, but now they have new controllers that you can do that with. So they are able to be done out there. A lot of the furnaces, you can set them up as two-stage, and you can have them auto jump up from first stage to second stage. We set them for single stage, but you can also set them for auto jump up from first stage to second stage as well after like 10 or 15 minutes of runtime. So you can do that with your furnaces as well. Um, also, yeah, I wouldn't do that. If I don't have enough wires, I'll find a way to fish a wire if I can. If not, I find a system that will work for the wiring I have. I would not just run a common wire to the line set. Yeah, it is making the connection back and forth, but um, I just would not trust that whatsoever. Because technically, it is technically yes. The copper wires is grounding because it is grounded to the system. It's all grounded together. You could take the common wire and put it in the cabin of the piece of equipment and be done with it. Um, I'll put it to you like this. I had a brand new carrier. Okay. And I'm going to draw you the picture of this because I missed it. Another senior tech missed it. And it took him a while until he figured it out. And we both missed it. So we were like, you got to be kidding me. Um, just going to draw it in this little half right here. So carrier heat pumps. Okay. They have that little white plug that has your control wires, right? R, Y, O, W, common. There's two blank spaces on this control. Well, I went and started this thing up because the guys were having issues and kept popping fuses left and right. So I went out there. If you notice, see how this one has the common next to the W, where this one has the common a space away from the W? The factory wired the plug up like this. This is the plug that goes into the circuit board from your low voltage connections. This is how it's supposed to be. I didn't have a common because this was in the wrong spot. See? Wrong spot, correct spot. So what I did was I took the common off the contactor and the common off the reversing valve, tied them together and screwed them into the circuit to the cabin of the unit just to get me a common to get the system running. Um, while we ordered another circuit, while we ordered the harness, reversing valve, control board, fan, defrost cycle switch again. We were replacing all the components again on a brand new heat pump, all because this was wired incorrectly. When the other tech got out there, he brought a board. He had to go back and get a second board. And when he was playing with it, he stopped and looked and realized, I think at the third board, that this was in the wrong spot. Thought I had that on quiet. So yeah, so even the factory will mess up, guys. If I mean, this right here was something so oblivious to me and to him that we both missed it. Installers missed it. When he finally sent me the picture, I said, what's wrong with it? He goes, you don't see it? I said, see what? Then he sent me another picture of it fixed like this. And I was like, oh my God. So, yes, things can happen in the factory and not be set right. Okay. I've had pins and the non-plug connectors for the heat strips not inserted all the way, and I go to plug it up, it doesn't work. It's because the power plug going out wasn't connected in and pushed in all the way and snapped in. So yes. Does it happen even to the senior technicians? Yes, it does. But unfortunately, nothing you can do about it. Just accept, fix it, and move on. So, all right, you guys have any questions on what we've gone over tonight, on today, on anything? Now, the next class is not for 2 weeks because I'm gonna do this every other Saturday, so I don't get a overextended with things I have to do personally with my family and stuff, but or whatever else I have going on in my life that week. But if you guys have any questions, feel free to ask them now. If not, um, go to the Chicks page, ask them there. Ask them on this once I get it posted to. Once it goes done, I'll post it. It'll be posted onto the YouTube page for you. Um, we're going to do this all low voltage as you saw in the events that we're going to do, and then we're going to move into another topic. And we're just going to keep doing that. We're going to do hour classes with about up to a half hour of questioning. I appreciate everyone coming. I hope you all learned something today. And for everyone who watches later down the road, I hope y'all pick up something and learn a little bit too down the road. Says there's 7 of us in here. So without further ado, if y'all don't have any other questions, I'm gonna bounce off of here and see y'all in 2 weeks. So y'all, everyone have a good week and what's left of it. If you got snow, enjoy it. And I'll see everyone in 2 weeks. You are welcome. Enjoy. And we'll start for the next one with more fun.